so I'm sandbagging because I'm already down to like 4 minutes and 30 seconds here, but I'm not going to take that long anyway. So what I wanted to share with you guys today is my love for the Z shell. And this is my little ode to Z shell. And I just wanted to share something that probably most of you do not know about why this shell is so awesome. I actually did a talk 2 days ago in Chicago, and that's actually why I'm really tired right now, entitled Ruby Pie Bake. And the reason why is because I did a whole talk about just being awesome with the shell. And these are actually the same slides, but I'm just whipping out the little stuff here. So on to Z shell, and why is it so awesome? Z shell is awesome because it gives you lots of control. And you know what it gives you control of? And I just want to show you one little simple thing. There's something called the escape hacks in Z shell. Anyone familiar with the escape hacks in Z shell? There we go, right there. You already know what awesome I'm getting ready to show the crowd. So right here, what we have here is you see that as a period, a quote, a single quote, a queue, and return. Let me show you what kind of awesome things you can do with those 4 things in Z shell. So with the period, so let's say I'm in a directory. Let's go to another directory. Oops. And where are we today? We're in Baruco, so we'll go to that directory. Let's say I want to create a file, and I'm just going to use cat to create a file, and I'm going to cat to foo. And then I say this is foo. So once I do Command D, sorry, I'm looking up and typing backwards at the same time here. So let's say if I want to do something else with that file foo, you could just do ls foo. But you know, Z shell says I'm more awesome than that. Escape. All right, so we do ls escape period. It gives you the last argument of the last commands you did. So it gets better than that. So here's something else you can do. So let's say you were typing out a long string. This is a long string. And then you said, you know what? That needs to be quoted. Escape quote. It quotes the whole thing. You get this for free inside of Z shell. All right, so let's think about something else. So let's say you're like me and you're saying, well, I was going to type ls-l because I type that all the time, but I didn't really want to type ls-l. I wanted to type ls-ltr. So whenever I do this, watch what happens. Notice that it did the ls-ltr, but it also put ls-l back on my command line. It allows you to have, I call it like lame brain programming here, whenever you want to do more than one thing at a time. So I think that's pretty awesome. So I wanted to leave. I'm not going to talk about Q. I wanted to show you this. I actually went around how I created that image. It's actually not the original. I actually split it up with FFmpeg and then put it back together, just showing how awesome Z shell was. So one little quick thing. I have only, oh, my time went away, but I only have a couple more seconds, but I want to show you something. In Z shell, you should not use ZD. You shouldn't use push D and push pop. You actually can configure Z shell to do this for you automatically. I think you can also do it with bash. And you can actually do dirs-v to see it, or you can use Z. Write this URL down. Actually, you can actually go to directories that you go to all the time. And one last thing. We need to be better at the shell. So if you don't know what these 6 things are, and you don't know how to use them like the back of your hand, you're really doing yourself a disservice because they're on every single Unix box you're going to find. So that's it. Thank you.
My name is Alberto Perdomo. I'm going to talk about a little bit about graph databases. So what is a graph database? A graph database is basically a structure of nodes. And these nodes can be connected by edges. And in databases based on graphs, you can store properties on nodes and also on relationships. And these properties can be the usual primitives, like string, numbers, and so on, Boolean. So graph databases are databases that focus on the relations between nodes. And this is, in that way, you can do very powerful queries where you really leverage the deep relations between different entities. And you don't have to think of it as a replacement for your current database. It's more like something you can use additionally. The same way like you use full text search engine and it provides you with powerful and fast queries. You can do that with a graph database. You can do powerful queries that you couldn't do otherwise with a traditional database. And it also provides you with a new way of exploring your data and getting, interpreting stuff and finding out. Usually in these relations, what you do normally is something called traversal, where you go through the relations from one node to another. And if we want to compare how you would do this with a traditional SQL database, a relational database. If you want, for example, this is an example of finding people you might know by exploring relations. And you can see it's really a bunch of ugly SQL code. And in a database, graph database, for example, this could be something like this, like 3 lines of code, because it's literally it's built for that. Yeah, funky. But there might be people out there that say, okay, I don't care really about the code. That, how about the performance? Maybe I can get, if I can get a good performance on my SQL, then I might buy that ugly code. So this is an example of retrieving the friends of your friends. And depending on the depth of the relation where you want to go, we can see that MySQL is not really an option. Like once you go to depth 4, it really takes like 25 minutes, the query. And this is for a data set of 1 million users, and you do a query on 1,000 users. So we are right now working on a product. It's called GrapheneDB, and it's a graph database in the cloud. It's based on Neo4j, which is a really robust and mature graph database. It's really transactional and full ACID for those of you that might be scared of losing data. And it's got a REST API and with lots of clients for different languages and platforms. And on top of what Neo4j offers, we want to offer powerful tools to manage and visualize your data. And we want to provide a lot of documentation on how you can use graph databases and for your applications and examples for different languages. So if you have a few minutes, it would be really cool at some point if you go to GrapheneDB and you can sign up for early access for our private beta. It will take still a few months, but you can sign up now. And you can take a survey, and so we can find out more about how we use them and how much you know about graphs. And that's it.
So anyway, I'm going to tell something about Cloudless. We built a new project in our company about Cloudless, the clouds list. We're trying to make a project that is like something like the App Store for web applications, or at least we're trying to be something like an App Store for web applications, or maybe something like the Chrome Web Store, but only for real applications, not for any games, or you don't have to install anything. So the reason why we built Cloudless is this morning Scott Chacon started his keynote with talking about first principles and removing frustration. In my company, we use an app for almost everything, and maybe there are some guys here which do the same. And if you try to find a new app for a particular need you have, it's kind of frustrating to find them. You have to Google around, maybe you use the wrong keywords, and then you're like lost on the internet because you can't find anything. You just find any ridiculous desktop applications you don't want to use, or it's kind of sucks. So, and we came up with the idea, why not build a website where we can put all these great apps. Everyone is working from day to day in a single place, and why not create a place where this is being presented nicely, and really nicely, not only a normal text list where you can just browse through, but with something like screenshots and more information, and maybe something like more social stuff. So, and in the end, it is maybe like an open stage for app owners who want to get traction in the first place when they're new to the market. It's always hard to get your project, to get some visibility for your project. So maybe it's Cloudless is the place to be. So, and how does our project look like? Yeah, basically it's this. This is the main screen. We have all these little app tiles with screenshots, the name, some text. You can see how many users are using this app, and you can like an app if you say, oh, this app is really nice. You can drop a comment. You can browse them by tags or search just for any free text. Then when you sign up, you get and you use some apps. You get your personal cloud list, and this is kind of a nice place to show some other guys which apps you're using. And this is the app detail view with some more information. You can see you can tweet about an app. You can get a share link. You can see who's using this app and get on their cloud list to see which apps they are using. Of course, we have a mobile optimized version, and unfortunately, the iPhone version is not ready yet. So you will see a welcome screen telling you that this is coming soon. So how to reach Cloudless? It's cloudly.st for just a web page. You can connect via Twitter, Cloudless apps, or just if you want to drop us an email or something, then it's cloudless@gmail.com. So maybe if you go there and say, okay, it's a nice project, I want to help those guys get some traction, make it public, get more apps on the list, you can maybe just spread the word, tweet about us, or it would be awesome if you add your favorite apps if they are not yet on the list, or just sign up and create your own cloud list. And yeah, okay. Thank you.
Awesome. Hello, I'm Marco. I work at RenderText, and most recently I'm most focused on Semaphore, which is a hosted continuous integration app for Ruby. And I want to talk to you, or maybe remind you just about some benefits of using continuous integration or CI. I think there's something that it does to your project even before you start using it, which is it sort of validates your stack. What I mean is that if it's difficult to set up and there are tools that make it really easy now, then you have a sort of problem or a challenge that you should tackle. And recently, for example, we had to sort of restart development on a project that we sort of abandoned. And we used the opportunity of, like, we decided we really want to have CI, so we used the opportunity to shave off some really unnecessary dependencies that we had at runtime. And we came up with this, of course, standard bundled, application, which is like you can hold it in your hand. It feels awesome. It feels like you're free again to do whatever you want. And when you're in, like when your app is in, what you get is basically automation. I assume you're writing tests, unless you're maybe working on a Polar lender. But the reason you're doing it because you want to make sure that your app is okay, and you cannot be sure unless you're testing all the time. And we as humans need to automate, otherwise we won't do anything all the time. So what you get is actually have much fewer bugs because you catch many problems early on. Of course, not all, but you get closer to the gap where you're like closing the gap towards 0 exceptions, and you can start like using your time and energy on things like removing code smells. I really recommend, for example, using this gem called Reek and hooking it up in your spec suite or something, so it kind of everything breaks if there's a code smell. It's really going to change you can do it file by file, but eventually it's going to improve your craft, for example. Now this software development thing is a lot about people and communication, and you may recognize like things like this coming from maybe somebody who's not really your team, but you're collaborating with. So how do you have to communicate like this stuff is breaking, you know, it's not, there are consequences, we cannot, you know, do this. So what we have found is that you need to have, first of all, like very efficient communication channels with everyone that people are following. And then your CI should be hooked up like in all of this. So everybody knows, you know, what's going on in the project state. And when it's given, I think eventually it sort of educates everyone what their actions like mean in all detail. More than that, CI should also make your work faster. Basically, it should be able to run your test suite faster than you can on your machine, so you can just really focus on, you know, what they call important tests. You run locally and then test your feature branch all the time in the CI, which lets you deploy more frequently. And when you deploy more frequently, you get more feedback from customers, from users, and you get more engaged client. More engaged client is usually more happy, and then, you know, there's more money for you maybe. So I think you should really, if you're starting a new project, start using CI from day one, but it's never too late. And if you're interested in a hosted solution, I encourage you to check out Semaphore. Our mission is to be the best hosted service for Ruby. And there's a coupon that you can get if you find me in breaks for discount. Thanks.
Oh, that goes. Well, hi. My name is Vasilis Rizopoulos, and that obscured logo there is the logo of the company I work for. Convenient. That's my Twitter account. Raise your hands. Who here has played or knows what World of Warcraft is? Really? Really? All of you guys need, all the other guys need to hang your heads in shame, call yourselves geeks, and so on. Anyway, I make it a point not to talk about anything serious when I do a lightning talk. So I'm going to talk about World of Warcraft and how it is a parallel to software development. In World of Warcraft, which is a massive multiplayer online game, you have these things called instances, where a team of 5, 10, 15, 40 people goes in and wants to defeat a boss, monsters, to gather loot, to earn money. Well, think of the raid instance as a software project. The boss at the end is your delivery date. And as every software project, it gets kind of complex. All kinds of stuff. Lots of information coming in and out. And in order to go through it and make it happen, you need a team. And in that team, you've got different roles. And I will show you how a World of Warcraft team parallels a software development team. Well, one of the roles in World of Warcraft is the so-called tank. And that's my answer to Scott. What's the use of managers? Why do we need project managers, product owners? Well, we need them to act as tanks. The role of a tank in World of Warcraft is to get the aggro, to keep all the buddies away from the team, away from the rest of the group, so they can do the work while the manager gets beaten up. A good manager captures all the aggro and lets the team work in peace. A bad manager lets the buddies get away and the project wipes. Now, next to the tank, you have the so-called DPSs. DPS stands for damage per second. Those are the coders. The more damage you do, the faster we get through the project. The more code you write, the better code you write, the more effective you are at your work, the more we do it. If you do it too much, though, if you deviate, if you start bringing new stuff, if you pull the aggro away from the project manager, the project wipes. And then, something that we don't really have in all the teams, you have a healer. The healer's work is to keep everyone alive. Whoever gets damaged, the healer goes in, makes him okay. Well, what's the healer in the software team? Your DevOps guy, your infrastructure guy, the guy who makes sure that the radiator runs, that your build system runs, that your continuous integration is there and will work forever. Keep him happy. Keep the buddies away from him, because he will make sure that you can do your work. Now, for those of you who have played World of Warcraft, you know that if you have a bad tank, the project wipes. If you have a bad healer, the project wipes. If you don't have enough damage, the project wipes. The instance wipes, the team wipes. It's all a matter of teamwork. And when the team gels, well, you get through the instance. That's it. Thank you.
Hi, I'm Ryan LeCompte. I'm here from San Francisco. I'm a Ruby developer over at Spreecast, author of a couple of gems there. The focus of this talk will be Redis Failover. So for most companies that are using Redis, this is how your setup typically looks. All of your clients read and write to a master, which is replicated to a slave, but things can go wrong. Master can die. This happened to Ruby Gems, rubygems.org, a couple of weeks ago. Their master died, and there was a pretty big outage. So what happens? Most of the time you're using Redis with Rescue or Sidekick, you're caching stats or you're caching full pages in Redis. I mentioned Ruby Gems. So what happens when your master fails? Do you lose jobs? Do you lose dollars, for example? A lot of companies are using Redis more and more for very important parts of their business. So what do you do when the master fails? Normally you freak out, right? You scramble to go and reconfigure your replicated slave as the master. You have to go and update all of your clients to point to the new master, because normally your Redis client just takes a single host that was pointing to the old master. And then how do you get it to see that new config? Well, a lot of times you go and you restart your Sidekick daemons or you restart various services in production. But that sucks, right? What do we really want to do? You don't want to do nothing. You want this to be a safe and automatic process, which just currently does not exist. So let's talk about Zookeeper. Anyone familiar with Zookeeper? Use it? So what's Zookeeper? It's an open source Apache project originally released by Yahoo. It is a Java-based project. What does it do? Very simply, it provides a set of primitives to help you build distributed and coordinated applications. And let me describe that. So a couple of things that it helps with is network partition. So let's say with Amazon, with EC2, the US East region gets partitioned away from the European region, for example. Right? How do you deal with those things when two services can't talk to each other, when the networks are split? It deals with quorum management. So how do I know how many nodes make up a safe group of nodes that you can trust its availability on the network? Zookeeper is replicated. It has high availability built in Zookeeper itself. It's ordered, but most importantly, it is battle-proven. Used by Yahoo, obviously. Netflix. Netflix is a huge consumer of Zookeeper. Used by Rackspace. It's the building blocks for Hadoop and HBase, also Neo4j. So how can I use this in my own infrastructure and architecture? You can use it for distributed configuration. So let's say that you have custom thread pools sitting out in production or other important things that you have running that normally is backed by a JSON or YAML configuration file. You can store your configuration in Zookeeper and have it be changed dynamically and have your separate disparate nodes be notified of those changes and reconfigure themselves dynamically. You can also use it for distributed locking, priority queues, leader election, group membership. So how can I use Zookeeper in a practical use? I used it to build Redis Failover. You guys may have heard of it. It's a Ruby gem that provides a smart wrapper around the Ruby Redis client. The way that it works is the clients register for Zookeeper for watch notifications. You deploy various node managers that monitor your Redis servers, and when they detect a failover, they write that information into Zookeeper, which then asynchronously notifies your clients. So here's the architecture. You have a bunch of Redis failover clients that are subscribed to Zookeeper. Notice they're not subscribed directly to Redis. Your node managers are watching your Redis nodes. In case one fails, the node managers write it into Zookeeper, and then the Redis failover clients get notified. So the important takeaway point here is that you want it to be safe. So if your master dies, or gets respawned as a slave, you don't want your clients to be writing to your master. You want it to be writing to the real master. And so this is an attempt to provide a safe failover. Here's an example of the client. You just pass it your Zookeeper servers. Write operations automatically get written to the master, and reads get round robin across your slaves. There are companies already using Redis Failover in production, notably Papertrail. So consider using Zookeeper in your architecture and helping you solve your next distributed programming challenge. I really encourage you guys to check out Zookeeper. I feel like Rubyists don't take advantage of it enough. And don't let your Redis servers go unmanaged in production. Consider using Redis Failover. And thanks. Ask me questions at the beach.
So I want to talk to you about Go. Not the programming language, but the board game. So what the hell has this got to do with the programming conference? I'm afraid your brains are weak. I hate to say it. You're, like a large percentage of us probably could develop some of Alzheimer's. You know, we do silly things like coding and katas. We don't really use our brains very well. So this game, Go, was kind of played by the royal families and going back in about 4,000 years ago now. And it was kind of used to teach, I guess, the young shoguns coming up about war. There's a great quote by a famous chess grandmaster. If they're sentenced being on other planets, then they play Go. Which I think is kind of cool, kind of old man versus alien. Confucius had this great quote, avoid doing frivolous pastimes and learn the virtues of this ancient and venerable game. And he said this in 480 BC, ancient game. This is how old Go is. It's one of the oldest board games. It revolves around life, death, and sacrifice, all parts of life. As you're learning this game, you start on a little small board, which is a 9x9 board. You progress, once you get a bit better, to a 13x13. And then you play real Go, which is on a 19x19 board. That's about 2 10 to the power 300 possible valid games, which isn't too bad. So develop a good brain. Chess, wow, yeah. 110 to the 120, yeah, it's, you know. Don't worry, we can help. So you play out the game, just taking turns placing black and white stones. And then ultimately you surround territory, which defines who wins, who has the most territory. Go has 4 rules. It's also one of the most simplest possible games. You can capture a stone simply by surrounding it. A black stone means the white stone disappears. It has no liberties, as we call it. It's dead. You cannot commit suicide. You cannot place a stone where it would immediately be dead. And Co. You cannot repeat the same board state ever. So one person could capture a stone, they couldn't immediately then play back, because that would replicate the board state. And the game ends by 2 humans agreeing passing, which is totally screws up computers, because computers can't deal with the idea that we just consensually say, yes, you kind of got that bit, I've got this bit. So computers are terrible at Go. It's approximated around 10,000 hours to become an expert at Go, which is about 30 to 40 years to become a master. If you haven't been playing since you're about 10, you will never be a master. So hey, you know, got to start somewhere. AI is terrible at this game. It's still incredibly weak. Even some of the most advanced AI techniques, there's a GNUI project trying to attempt to have AI to play Go. Like, anyone can thrash it. It's so stupid. The permutation space is so big. The level of kind of analysis and moves that are going on is so complex that AI still can't deal with it. Yeah, aliens win. But the great thing is children win. There's a saying in Go that once a child has stopped trying to eat the stones, they will beat any adult. And this is true. In China, there's a child who actually hasn't got the skill yet to pick up the stones and place them. So he just kind of goes like that, and the parent places the stone for him, and he can beat like 60-year-old men. So this is great for developing children's brains. It's also great for developing long-term memory, for developing planning skills. Teenagers, apparently, it takes a while for their brain to mature in terms of the planning side. So this has been great, reducing Alzheimer's. So if you want to talk about Go, I have a bunch of boards with me. I'll bring them tomorrow, and I'll bring them to the party. Just come see me and ask. Thanks.
Hello? Yeah. Hello, my name is Sergio, Porras in GitHub and Twitter and everywhere else. My talk is called like this, or also pronounced checkmark or Unicode character. I forgot the number, sorry. A couple of weeks ago, or a bit more, some weeks ago, there was this great conference by a lake in Berlin. There was a very interesting conversation about operators and its legibility, its overloading, etc. Then Chus, who is like there, mentioned that he once wrote a method like this, which I thought it was a very funny method. Actually, the conversation went on with very good points about expressiveness, cleverness, but, well, I have some concentration problems, so, well, I could only think of one thing, this awesome method. Actually, I kept thinking, how could it be even more awesome? And the answer was, well, actually making sense, semantically speaking. So I connected this thought with the known fact that the world needs more testing libraries, because everyone knows that the world needs more testing libraries. And armed with README-driven development, I wrote this, which I think it's a very cool code snippet, because I don't think you can pack more semantics in a shorter method name. That's things that should be true, things that should be false, things that we still don't know if it should be true or false. So I decided to start an experiment to know how deep our everyday tools support Unicode. And write this. Let's go. OK, I started by creating the project. Putting some files in it, and, well, it worked. So my shell and my file system were up to the task. OK, next, my favorite editor, TextMate. I opened the project, and, well, it also worked. So great for the editor, too. Well, the next thing, I wanted to create a repo, of course, to store my code. So I did. I added the files and committed. Well, problems started here. Like, probably Git didn't like this. But don't go so fast, because actually, I cloned the repo. Well, it was there. It had worked. It was only a presentation thing. So, well, Git was kind of great, too. OK, let's start some code, some Ruby. Things are interesting here now. You all know you need this to do this task, of course. So, well, I started writing the code for my library. And, of course, that didn't work. But don't go so fast again, because the problem has nothing to do with Unicode. The thing is that constant must start with an uppercase letter, and that is no uppercase letter. So, well, it's a bit less cool, but it's OK. And it allows me to write my, to the moment, favorite snippet of code, which is this, which works. So Ruby, perfectly OK. It was great. OK, the next part was GitHub. GitHub silently changed the name of my repo. So, well, GitHub actually failed for this task, but, well, I love you anyway. Then I decided to push my gem to Ruby gems. Actually, I could create the gem, perfectly OK, no warning, everything OK. But, well, when I tried to push it, it seems you cannot do that. So, well, Ruby gems failed too, but, well, it's a very cool tool still. So that's all. You can test it and write it. It would be very cool that you could do that, but actually, as I told you, you cannot do that. You must do that. But it's OK. The thing is that breaking things is very fun, and actually creating things that are already broken is very fun too. Thank you.
All right, can you hear me? Okay. Well, after this great introduction about AGI by Paolo, I really love you as well. I mean, I was at the same Triagon conference you were last week, and we should hug after that. Okay. So after that great introduction, I would like to introduce you to one of the practices we use in Agile teams. And I'm going to do a small exercise because I know that you guys like to raise hands. So how hard it is to cut those fruits in one eatable piece. By eatable piece, I mean something like a cube of 1 centimeter each, and something you can put in your mouth without removing anything and start to chew. Okay, let's take this reference. This is the apple. I'm just going to slice it in 4 and cut a small size and then just eat it. I'm not going to peel it off. And I'm going to give it a value of 3. Now, I'm going to ask you guys, do you think that for this fruit, it is more complicated and more difficult than the apple or easier than the apple? Okay, all those that think it is easier than the apple, please raise your hand. All those that think it is harder than the apple, please raise your hand. Okay, I want one of those guys to explain why it is harder. Anybody? Please, just one. I only have 5 minutes. Okay, it's smaller, but you don't have to cut it, right? You can just put it in your mouth. You just have to remove the green thing. That's probably... Sorry? Always overestimate. Okay, all right. Good. Whatever. As you wish. What about this, the orange? Whoever thinks that it's easier than the apple, please raise your hand. Who thinks it's a little bit harder than the apple, please raise your hand. Who thinks it's harder, much harder than the apple, please raise your hand. All right, you see, we kind of have this. Now, the interesting fruit. The coconut. Who thinks it's actually easier than the apple? Okay, we have one guy. Thank you, thank you. I'll come back to you right after. Who thinks it's actually a little bit harder than the apple? Who thinks it's much harder and more complex than the apple? Okay, one of the guys that said it's easier. Please explain how you do it.
Put it to the oven.
Okay, that's one way to do it. Okay, any other solution?
Take a machete.
Hit it with a large hammer. Perfect. Well, that's one technique, right? You just hit it, you have a piece, you put it in your mouth. The guys that said it would be harder, how would you do it? Guys, come on, don't overestimate. I'm just saying it. Okay, all right. Well, you see, my point is that the greater the task, the harder it is to estimate. And the harder it is that you're going to fall into the uncertainty cone, or you're going to see yourself overestimating, or just, I don't want to take too many risks or too much risk. I'm just going to overestimate this. But why do we bother estimating if it's not reliable? Well, there's one thing. In 5 minutes, we couldn't really do it a lot, but it's all about the discussions. It's not about the number that you put in your estimate. It's about how you guys are going to talk about how you're going to do it. There's one guy that says, okay, I'm just going to smash it with a hammer, and the others can say, I'm going to get a saw, and I'm going to do something like that, and then I'm going to remove it with a spoon and all. It's like that in any software development team, or for every software project. Some people have an easier way to do things, and some other people don't. And it's not necessarily the senior developer that has all the answers. But once you have that, how can you actually link it with time? Well, one small exercise on how you can get your team workload. How many cookies can you eat in 1 minute? Please, everybody, raise your hand. Please, come on. Come on, 1 minute left. Come on, everybody raise your hand. I'm just going to show cookies. When you think it's too much, just lower your hands. Okay, 1 cookie, you think it's okay in 1 minute. 2 cookies in 1 minute, 3 cookies in 1 minute, 4 cookies in 1 minute, 5 cookies in 1 minute. Okay, more? 7? 8? I should have brought cookies with me. Seriously. Okay, this is exactly the same kind of things you can do in your team. You can basically put just stuff that they just estimated and just say, okay guys, do you think it's still okay? If it's not okay, then we stop there and we try with this. I had many more cookies. And you can basically just say, okay, this is the number of things that we're going to do, or this is the overall estimates that we're going to do this iteration. This is how we estimate in an Agile team. Thank you. Sure.
I want to talk about a project I started open source recently. It's called Aston, and it's an alternative to StatsD and Graphite. For those who don't know what StatsD is, it's an open source project from the guys at Etsy. It all started with this post they wrote about measuring everything and anything. And it's basically, they wanted a very easy way to allow developers to push metrics and collect them in an easy way. So they went for StatsD, which is a server that allows you to do counters, timers, and gauges. And it's a very simple UDP collector. You just send UDP packets to it, and it flushes eventually, like regularly, to Graphite. Why UDP? Well, this is basically what Anthony explained before. It's a fast protocol. If I forget, you don't have to deal with connection timeouts, or just you don't have to establish a connection at all. So they went for that. And the client is also very simple to write. The client, the Ruby library is like, I don't know, 60 lines of Ruby. And this is a code to basically send metrics. So we wrote Aston, which is something very similar, but written in Ruby, but with some other stuff. It's API compatible, so you can, it's a drop-in replacement for the StatsD. There's no storage engine. It's separated like Graphite. You can store everything the same. It's an in-process database. There's no configuration. You don't have to declare the metrics you want to store beforehand, so you just start sending them. And you have like a event firehose with all those metrics you're collecting, so you can graph them easily. It's basically these two projects. It's based on this technology. It's password compliant, obviously, like everything in Ruby. And this is how it looks like. This is the dashboard you will get. This is the metrics you're sending here. So you're sending some values, 300 milliseconds, and this is like the interface you get. Live metrics, an archive, and alerts, also based on the metric trending. That's basically, you can, it's on my GitHub repository. That's my Twitter handle. If you want to try it, that's it.
Good. So, as you can see, I'm not a very good techie. So I'm going to tell a very, very short story of what happened to me. That being a very average or shitty to average programmer, I still managed to do something. And I just want to send you a message to say there's hope, even for those of you that feel overwhelmed standing here and see how many great people there are and how much stuff we should learn to get something done. So I'll just share my story, and hopefully you find it a bit either inspirational or you can throw tomatoes at me. So what did I do? I am a programmer. I did programming for about 12 years, and I learned a lot. So I did Java, I did portals, I did patterns, I learned a shitload of gems, I did really, really many things. And after 12 years, I said, okay, I'm great, I'm really seeing a lot, and I still haven't achieved anything at all. So I'm earning pretty much the same money I used to. I see all these companies, you know, all these people doing startups, and I had nothing. And I was really upset and depressed and said, why? Why, even if I studied so much, even if I'm putting so much effort, I'm not really getting anything done. And also I couldn't buy a house, buy a car, but a disaster. So, so I sat down a bit and I had a bit of a reality check moment, say, what's the problem? What am I doing wrong? So what is really important? What am I missing? Where I'm spending my time? So why do we develop softwares in the first place? We need to solve some problem. So we need to produce something that's useful for someone. So we need to have a software that either transfers money from one place to the other or solves a problem that someone has got. That's the end goal. We need to solve a problem, because if we only spend time by setting up CI boxes or perfecting the techniques, but we don't really produce value for someone, well, we're going nowhere. So I said, okay, from now on, I'll change a bit my mentality and I'll only focus on doing something that matters for someone. So I had to find someone that was willing to pay for something. So I went around and listening for opportunities. And my girlfriend was working at the time at a language school as a secretary, and she said, oh, the database they got there, kind of sucks. And they called me and say, oh, can you do something? Can you create a tiny program? And they screamed, they wanted to say, I'll pay you to do something. So I said, okay, this is someone that really cares about a problem that, I might solve. So I sat down and I say, okay, I found someone who's willing to pay. Now I gotta do something about it. And I started this software as a service to manage language schools. Very boring. You cannot pick a worse, project. no one would like to do it. And I thought, is that the right market? And I saw all of my friends, all the clever people, were doing stuff for techies or to-do lists or remember the milk or something like that. And I said, oh, actually, this market could be quite cool because owners of language schools don't like change. So they're unlikely to switch from my product to another one. And also, management products, I mean, this sort of software where you enter data, you move students from here to there. It's very simple. It's like big CRUD applications. Maybe I can manage it. I mean, it's not that difficult. And it was sort of the right market for me. I didn't need to be too clever, compare myself to the good guys. So that was kind of within my comfort zone. But still, I had in my projects folder, in my computer, like 1 million different tiny projects unfinished. So I was worried, will I ever finish this? Will I ever get it done? Okay? So you'll hate me because I went against pretty much every good thing you guys said today. What I did, and against what I learned, in the previous years by doing contracting or software development for multiple companies, I said I'll only write tests for the stuff that can really, really, really go wrong. But I won't have a full coverage. I won't upgrade my computer. I won't upgrade Ruby. I won't use any new technique. Actually, I stopped reading blogs altogether. I didn't upgrade or install new gems. I said, okay, 2008 or 9 when I, that's the end of my knowledge. Started that. That's fine. I stopped reading mailing lists and I stopped attending conferences. So I attended them. Oh. Can I go on? Can I go on? Okay. Thank you. So I used to do many conferences, Java. Before I met James Gosling, the creator of Java, I spoke at multiple events, the Redis Conference with plugins, open source, and all that bullshit. And I said, okay, stop, no more conferences, no Twitter, no Facebook, nothing at all. My life now is just to produce something that's useful to someone, which are these old ladies who teach English. So only fucking features. That was the only thing I had to do was to implement timetables, to register visa students, the very, very boring things. Okay, so I started doing that, and I went through big constraints, money constraints, and time constraints. So I started working on these side projects early in the morning from 6 to 8:30 in the morning. Then I had a job as a, I hate to say it because you kill me, as a product manager. And, and then I came back home, I did another hour. So I only had like a couple of hours, 2-3 hours a day. If I started doing fancy stuff like the Redis or this and that, I would not be able to ship something. So I had just to do whatever was needed to provide, to show my customers, these schools, some progress every day or every week. So I went through very painful few months, and then another school saw my product online, then another one, and one from Ecuador and one from Taiwan. At some point, they were calling me during the day, during my job, and I said, okay, I cannot take all these calls, I cannot demo the platform, and I quit my job, and pretty much wasted all of my savings in the following 9 months. And I was almost broke, but I stuck with it because the people that were using the thing were really happy. All of my colleagues, all of my programmers' colleagues, they were looking at me like shocked, saying, what a pile of shit that you're doing. But in reality, the schools were finding it useful. So I kept going, and I stuck with it because I knew that that was providing value to someone, and someone was willing to pay to use this and to solve their problems. One of the challenges that I faced is that I still was sort of passionate about programming. When you're passionate, passion can drive you through, can make you do beautiful things, you do the beautiful interface, you do the beautiful architecture, but it's a bitch because you only do what you're passionate about, and you might not do what you actually have to do. I mean, doing software for language schools is not fun. I mean, it's really, really, really boring. But passion can make you waste a lot of time in the wrong direction. So, yeah, you should be passionate about your stuff, but you also should think, this is actually work. If I want to achieve something, I got to do also the amount of shit that no one wants to do. So I went through this, and luckily enough, I got more customers. Investors saw the product online. They thought it was a good idea to merge with other ideas. They put some investment in the company. I could finally hire a fantastic team of people that fixed or are fixing all the shit code that I wrote. They hired a sales team. The company's growing. We moved to another country. We got a nice office with 12, 14 people now working from something that that started as a sort of forgotten child, and that's it. So my message is, even if you're not great, or even if you feel that you're not always using the right techniques, or there's always hope. Just focus on something that matters for someone and keep going, because good things do happen. That's it.